Swayam Prabha. Digital India. Educated India.
Hello and welcome back everyone. We are learning the basics of building construction and we are studying the module on damp proofing. In the previous lecture, we started talking about what is damp proofing and what are the materials we can use for it, the various types of damp proofing methods that we can use. We also understood how we can do damp proofing at the foundation level, floor, wall and roof level. So today we are going to talk about the roof level in particular. We will understand how we can do flat roof terracing to ensure that moisture doesn't enter our internal spaces. So let's get started. But before we get into the nitty-gritties of damp proofing on roof surfaces, we have to get a little bit of a quick glimpse at what we are talking about when we say a roof. A roof may be defined as the uppermost part of the building. They provide a structural covering to form protection from rain, snow, even direct sunlight. They require adequate strength, stability and resistance against moisture. Heat gain, fire and of course soundproofing is also required at the roof level. The different types of roofs that we can have include pitched or sloping roofs, flat or terraced roofs and curved roofs. So in today's lecture, though we've already studied different types of roofs that are possible in our buildings, we are going to pay special attention to flat or terraced roofs. And we will see how we can ensure that our flat roofs are damp proof because they do not have the advantage of pitched roofs and curved roofs where rainwater doesn't accumulate. It slips off or slopes off the upper surface, but in this case there is the problem due to our parapet wall and the flat nature. Water will accumulate during rainfall at least for a short period of time on our roof surface. So we need to take extra care to ensure that we are protecting our internal spaces from damping. So the typical examples of pitched roof or slope roof, in this case the water of rainwater can slide off, collect in the gutters at the end and can go down the storm water drainage that is provided. Of course in curved roof, not much of water accumulation would possibly happen. But in case of a flat roof, especially if it has parapet walls on the sides, the water will accumulate in it just like it would in a tank. There are ridges and valleys which are slopes created on the surface to ensure that the water flows in a certain direction and collects in the rainwater pipes that are provided in the corners. This is the storm water drainage that we provide to collect the rainwater and take it to guide it to the drainage system. So that slope will ensure that the water will flow. However, it will not nearly be at a rate or speed at which it would have happened on a pitched surface. So definitely a certain amount of accumulation will happen for a short period of time and our roof surface should be treated in such a way that it is able to protect itself and does not allow the moisture to penetrate into the internal surfaces or affect the ceiling or the walls of the building. So let's learn a little bit about flat terraced roofing. So what do we mean by a flat roof? Any roof which is either horizontal or practically horizontal with a slope less than 10 degrees is going to be referred to as a flat roof. So even a perfectly horizontal roof requires some amount of slope. It is never 100% flat. We do not make it at 0 degrees. At the top there will be a certain slope to it, even if it is a very minuscule slope, because the rainwater has to be drained off easily. So flat roofs are built much like intermediate floor slabs using materials such as flagstones, rolled steel joist, reinforced cement concrete or RCC, reinforced brickwork. We can also use jack arch roofs or precast cement concrete units to make the flat roof. So we have n number of options to use different types of structural systems, different types of materials for the construction of our flat roof. The most common type is of course the RCC roof slab, which we create using RCC in a certain thickness, and it is very similar to what we are doing in the intermediate floor levels as well. only in this case this is exposed to the external weather elements. So that is the final roof structure. The distinction between the roof and the intermediate floor slab lies in this top finish, which is referred to as terracing, which shields the building structure from weather damage. So every intermediate floor and the construction of the roof slab will be the same when we are talking about RCC. The only difference is, if it was an intermediate floor, we would have topped it off with flooring material, because we are going to use the internal space above it as a room. And in this case, if we are dealing with a terracing material, which is going to protect this building from external weather elements. So it is the final cover, rooftop covering, that is provided at the top. Now there are many advantages to a flat roof, despite the fact that unlike a pitched roof, the snow or the water from rain is not going to drain off as easily in this case, but there are many advantages to constructing a flat roof. The construction and maintenance is easier, because in case of a pitched roof, you know that we use thatch or tiles to cover. In case of storms, a lot of damage can happen on our pitched roof. Definitely it requires regular maintenance. Every few years we will have to treat the upper surface to ensure that the integrity of the roof is maintained. But though initial investment in a flat roof is higher, its durability and longevity is much more. It also doesn't require very regular maintenances. It can be easily made fireproof. That is one of the major problems with pitch roof, especially the ones which are made with timber or thatch. They can catch fire very easily and can lead to devastating situations. But in case of flat roof, especially the ones which are made using rolled steel joist or reinforced concrete, definitely very fireproof. They can provide better architectural appearance and functional use of space in the buildings, because the roof is going to be accessible and humans can use that space for additional domestic activities such as drying of clothes or even other spillover household domestic chores. It also provides a wonderful place for spending time or doing socialization activities. So that also provides an additional edge to our architectural design. That option will not be available in case of a curved or pitched roof. This has better insulation properties. They are economical in comparison to the other types of roof, especially if we take into consideration the long-term maintenance and recurring costs which are associated with other types of roofs. For multi-storied buildings, flat roofs are the only roofing option, because it requires the positioning of an overhead water tank. There are other services which are provided on the terrace. So definitely for high-rise buildings, we will have to go for a flat roof. Vertical extension of building is also very easy, because we can add more floors or stories on top of the existing building anytime, because it is a flat surface. If we had a pitched roof, we would actually have to replace it with a floor slab, then continue construction above, which would be difficult. It can be used as a terrace for playing, gardening, sleeping or other celebrating functions or social events as well. The span of the roof is, however, restricted. There are certain disadvantages of flat roofs. One major problem will be that we cannot have a very large span. In case of trussed roof, pitched roofs, we can have very large spans, and depending upon the span that we are dealing with, we can select the type of truss that we use in our roofing structure. But in case of a flat roof, we have to provide intermediate columns depending upon the span. So beams and columns will have to be introduced, and internally the space will have to be divided with the help of these columns. So definitely the columnless span of large spaces cannot be done in case of flat roofs that easily. The self or weight of the flat roof is also very high. It results in larger number and size of beams, columns, and we also have to increase accordingly the foundation and other structural members, because the self weight of these roofing slabs are going to add to the weight and overall superimposed loads being placed on the foundation. It is unsuitable for places where very heavy rainfall or snowfall is evident, because of the rainfall which actually collects This can increase the vulnerability due to dampness. So in those situations or places where a lot of rainfall happens or snowfall very commonly happens, we have to opt for a pitched roof instead of a flat roof. It is vulnerable to the development of cracks due to thermal expansion and contraction due to seasonal changes, and these cracks will then open up vulnerability towards moisture penetration. So that is one major problem which is associated with flat roofs. So definitely while making flat roofs, we have to accommodate this thermal and expansion and contraction seasonally in the design of the structure. It is very difficult to locate and rectify leaks in flat roof over time. It's not as easy as finding out one missing tile on a pitched roof and replacing it. A hairline crack which might have formed in a certain position will lead to penetration of moisture through that and will damage the internal spaces. Might be very difficult for us to locate it on the roof surface and repair it over time. But of course, one may note that the formation of such cracks don't happen very regularly. If there is proper workmanship done, proper terracing done, there is a fair chance for several years no such damage will be noticed. The initial cost or investment in this type of roof is very high. Overall cost of course is lower than other roof types if we take into consideration the recurring cost which happens over the lifetime of the building. This is exactly why in case of kacha and semi-pakka houses, the most common phenomena is that we do not have a flat roof, because the initial investment is very high. Not everybody can afford to have a flat roof in the first go. So probably only people who can afford to go for a pakka construction would avail this type of roof. So many a times we'll see in semi-pakka constructions, the walls are made up of brickwork or stone masonry, but the roofing structure is pitched. It is not a flat roof because the residents or the households have not been able to afford that initial expenditure that a flat roof entails. So these are some of the disadvantages of using flat roofs. So now that we understand what we mean by flat roofs, that is roofs which have less than 10 degrees of slope, and we also understand what are the advantages or disadvantages of architecturally applying this type of roof in our construction. Let's now dive into the type of flat roof terracing that we can do. What is the material that we can use to top up our roof construction? So the idea of creating RCC roof slab is very similar to what we do in the intermediate floors. So we're not concerned now with the structural elements. We are going to concentrate on the perspective of terracing or the material that is used on top to prevent damping, which is why it is an extension of the damp proofing module that we are studying. The first type that we can use is the mud terrace roofing. As the name suggests, adobe is involved in its construction, followed by the brick jelly or madras terrace roofing, the mud fushka terracing with tile paving, followed by lime concrete terracing and lime concrete terracing with tile paving. Bengal terrace roofing is another type, followed by lightweight flat roofing. Now we are going to take a look at each of these types of roofing constructions in detail to understand what are the materials that are used, what is the layers in which they are placed, and what is the time required for the construction of each type of terracing. First, let's start with the mud terrace roofing. This is suitable for areas with less rainfall. It can be used over tiles, which is very commonly observed in Punjab, or it could be on wooden boards, which is more commonly seen in the states of Maharashtra and Madhya Pradesh. So these type of roofing structure can be applied only when not much rainfall is received by these areas, and in both these cases the terracing is made up with white earth mud, which is containing a large percentage of sodium salts. Now the top layer of this has to be renewed annually because it undergoes significant damage throughout the span of the year and has to be reapplied and renewed every year. This type of roof does not leak very easily and it provides good insulation against heat gain. The main reason for this is the white color. The white earth actually provides a layer on top of the surface or the roof surface, not allowing for much of heat gain seasonally. Let's see how in detail the construction is done in both the types. That is the first example used in Punjab, where we have mud on top of tile terracing, and the second type in which mud is applied on wood terracing. So 50 mm cross 50 mm cross 6 mm T sections are spaced at 32 centimeters center to center, and they are placed over roll steel joist. So let's say the roof is made up of roll steel joist, on top of which we are placing T sections spaced at 32 centimeters center to center. On top of this, well burnt tiles, which are of size 30 cross 30 cross 5 centimeter thickness, or we can go for 30 centimeter cross 15 centimeter cross 5 centimeter in thickness, and they are placed between the flanges of the T section. We use lime mortar to fix them in position. So once that is done, a 15 centimeter thick layer of white, stiff white mud which contains sodium salt is spread, and it is beaten with the help of sticks, and we will continue beating this surface until it becomes hard and until the beater starts rebounding. So that's when we know that the process is complete. This surface is then plastered with mud and cow dung mix plaster, and it is finished off with a 1:4 cement cow dung plaster. This is the way we do it on top of tile terracing in case of the Punjab example. So let's now take a look what happens in Madhya Pradesh or Maharashtra example, where we are dealing with a wood terracing. So here teak wood boards 4 to 5 centimeter in thickness are nailed on top of wooden joists, which is the main structural element of this roof. A 2.5 centimeter thick layer of wood shavings is spread all over the boards. Now once this has been done, bricks are laid on edge in lime or mud mortar on top of these wood shavings. 8 to 10 centimeter thick layer of mud is then spread, and again similar to the previous process, we beat it into a hard layer. Finally, a 2.5 centimeter thick layer of white earth containing high percentage of sodium salt is applied. So in both the examples, we may have roll steel joist or wooden joist forming the base, above which, in case of the previous one, we are placing tiles. On the tiles, we are placing the thick mud surface with sodium salts, beating it and then finishing it off with a mud cow dung mix. In the second example, on top of the wooden joist, we are placing wooden boards, then wood shavings, then brick on edge, followed by a layer of mud, then finishing it up with a layer of white earth containing high sodium salts. In both these cases, we are ending up with a white surface on top, which will help us in protecting the internal spaces from unnecessary heat gain in summer. So that was the first type of terracing material that we can use. The second type is called brick jelly or Madras terrace roofing. Now this is a very traditional roofing technique that uses handmade bricks, wood and lime plaster. It is a good choice if you are going for rooftop gardens or we want to apply solar panels on top in traditional constructions as well. So this process of construction can be segregated into 7 steps. We will take a look at all of them in detail. The advantage is that it is very easy to construct, it is durable, and very effective waterproofing can be done. It can also reduce heat gain. It requires less construction material as well, not much wastage happens. The disadvantage is that it requires regular maintenance, and slope and design of the roof may limit the usability of the floor. So accessibility and the usability of the upper surface might be reduced. So if you are going for simple gardening maybe, or installation of solar panels, we can use this type of roof, but if you want major access to the roof for activities, it might not be the best option for us. So here, let's take a look at what is the process of construction. The first thing we do is wooden joists are placed on roll steel joist with a furring piece in between to form a slope for the roof. So a slight slope is required to help drain rainwater. Now once this wooden joists are placed, a course of specially prepared bricks These bricks are of size 15 centimeters cross 5 centimeter cross 12 mm, is placed diagonally across the joists. So, if the joists are in a certain direction, we are diagonally placing the bricks across. On edge in lime mortar of 1:1.5 ratio. A 10 centimeter thick layer of brick bat concrete is laid finally. So, 3 parts brick bat, 1 part gravel and sand, 50% lime mortar by volume. So, we will place a thick layer of this brick bat concrete about 10 centimeter in thickness on top of this special course of bricks. The concrete is then well rammed with wooden hand beaters until their thickness reduces from 10 centimeters to 7.5 centimeter. The surface is cured for about 3 days and 3 courses of Madras flat tile 15 centimeter cross 10 cross 12 mm are laid in the lime mortar to form a cumulative thickness of 15 mm. Vertical joints of the tiles in successive layers should be broken, and the joints of the top layer are kept open to provide key for the top plaster, which means that finally we will have a top surface of plaster with 3 coats of lime mortar which are rubbed and polished to finish. So, 7 exact steps in which the Madras terrace roofing is done. Let us take a look once again at the figure. So, we have the roll steel joist. With the help of the furring piece, we are placing the timber joist in this layer. On top of this, we have a special layer of bricks. Then we have a brick bat concrete which is initially laid at 10 centimeter thickness and it is beaten to 7.5 centimeter thickness. And then we have multiple layers of these flat tiles such that the joints are not coinciding in each layer, they are spread out. Finally, on the top, we leave the joints open to act as a key for mortar, and then we have the final layer of plaster which is placed on top to finish the surface to make it usable. We have to ensure a significant slope in this type of roofing system. So, that was the process of the Madras terrace roofing. The next method that we can use for terracing is called mud fushka terracing. This is very suitable for hot and arid climatic regions. It is commonly used over RCC roofing. The previous examples, we can use roll steel joist or wooden joist for the construction of the roof. Now we are starting to talk about RCC roofing and the type of material that we can use for terracing on the same. Now this construction requires 5 steps. The advantage is that it provides a cooling effect during hot weather and it provides warmth during cold weather. It is very durable. Clay tiles have a very long lifespan. The disadvantages is that it requires regular maintenance and clay tiles cost more than other materials, and the weight of the clay tiles may also add a lot of load to the superstructure. Let us take a look at the process, then we will come back again to the figure. 5 steps to be followed in the mud fushka terracing. The first step is that the RCC slab is cleaned from dust and any loose material. After we have cleared the entire surface, we do not want any debris because we are going to place the first layer of DPC. So, for damp proofing, we have to ensure that it has to be applied on a very clean surface without any projection, otherwise the layer will get damaged. So, we clean the RCC slab and we put a layer of hot bitumen paint. Now, this is spread over the entire surface of the roof at the rate of 1.7 kg per meter square. After this, in the second step, we have a layer of coarse sand which is immediately spread on the hot bitumen paint. So, before the paint of hot bitumen dries up, we provide a coarse sand layer on top of it at the rate of 0.6 meter cube of sand per 100 square meter cube of the roofing material. Now, the mud fushka, which is prepared from puddled clay mix with bhusa or chaff, is laid in a 10 centimeter thick layer over this sand bitumen layer that we have created in the first 2 steps. So, this is the main material that gives this type of roofing its name. mud fushka. It is prepared separately, and then on top of the bitumen and sand mix, we are going to place this layer in 10 centimeter thickness. Now the mud fushka layer is consolidated properly, and it is plastered with a 13 mm coat of mud cow dung mixture mortar, which is created at a ratio of 3:1. Finally, in the fifth step, the bricks are laid flat on the plastered surface, and the joints are grouted in 1:3 cement mortar. So, bitumen, sand, mud fushka, cow dung mud mix, and finally a layer of bricks laid on the plastered surface with help of 1:3 cement mortar. The next type of terracing that we are going to study is called the Jodhpur type or the lime concrete terracing. It's a method of laying concrete in layers on a flat roof to provide waterproofing. In the Jodhpur type, the concrete that we use has 2 parts of lime, 2 parts of surkhi, and 7 parts of brick ballast. Each layer of concrete is sprinkled with lime molasses mixture to create a waterproof layer. This total process has 13 steps to be followed. This type of roof is very eco-friendly. It has good adhesion and is easy to construct. However, it requires regular maintenance, has low compressive strength, poor durability. It takes a long time to harden and may contain soluble salts that can damage the brickwork or stonework used in construction. Let's take a look at each of these steps that we have to follow. So, the first step is that the longitudinal joints between the stone slabs are first pointed in cement mortar. For this, we need to know the different types of pointing used, which have been covered in another lecture. The joints should be V-shaped such that the top gap should be 25 mm and the bottom gap should be about 10 mm. This joint is filled with cement mortar mix. We can use a ratio of 1:2 to 1:4, and it is picked with stone chips of a wedge shaped, and the top finish is rounded with cement mortar to project a little above the slabs. Before filling mortar in the joints, flat strips of timber should be kept along the joint on the other face of the stone slabs so that the mortar does not fall. In the fifth step, the space left over the wall at the end of the slabs and the space on walls between the slabs where the roof is continuous should be filled with 1:2:4 cement concrete, and the joints should be properly cured for at least 7 days. To provide a proper slope to the roof, the rultal is laid along with a stone spall in 1:2 lime mortar over the surface of the slabs in the required thickness and is cured for again 7 days. Hydraulic lime or conker lime should be used for this process. On day 1, the unslaked conker lime, hydraulic lime, which is about 10 centimeter in thickness, is spread over the roof slabs. The lime is then slaked in situ by adding water. It is then beaten with conical stones by hand so that no particles of lime remain unslaked, which can lead to the formation of blisters. So, that happens on the 7th step or day 1, after following of course the initial process that we have gone through. On day 2, the lime is watered, raked up, and again the process of first day is repeated. On day 3, a combination of 250 grams of finely chopped hemp and 750 grams of finely powdered methi is evenly mixed with lime per 10 square meter. Then this entire mixture is topped up with coarse sand aggregate, which is duly washed. This is spread over the lime in a thickness not less than 10 centimeter. The coarse aggregate is thoroughly beaten with conical stones by hand so that this stone aggregate gets well embedded in the lime mass that has already been applied. After this, on day 4, stone grit or screening is spread in a layer of 40 mm and beaten with stone beaters till they are all set, and the water should be sprinkled till the whole mass becomes stiff and offers resistance to penetration. The thickness of lime chhat should not be less than 15 centimeter at any place. The work done in the above 4 days should be cured for at least 7 more days. After 7 days, a santala coating, which consists of cream of lime, is laid over the lime chhat in thin layers, and it is rubbed for 4 hours or more using rounded pebbles to create a polished finish. And in the final step, this surface which is prepared is cured with water for at least 15 days. We can use damp sand or gunny bags which are placed onto the surface. This ensures that the surface remains damp throughout the 15 days post construction of this type of terracing. So, this is the construction of Jodhpur type lime concrete terracing. We can do lime concrete terracing with tiles as well. This is a commonly adopted method. We can use it for RCC roofing. A technique of laying 2 courses of flat brick tiles in 1:3 cement mortar over lime concrete. The advantages of this type of roof is that it's very eco-friendly, it is durable, it is easily moldable, it's got low maintenance, it's sustainable and is cost effective. The disadvantage is that grout between tiles can wear off over time, which may lead to water leakage. So, what we do in this case is, the RCC slab is topped up with lime mortar layer, followed by multiple layers of brick flat tiles in 1:3 cement mortar, and that is giving us the final finish that we require for our terracing. The process which is followed for this is, the RCC slab is cleaned off, all dust and debris is removed. A layer of hot bitumen is applied at the rate of 1:7 kg per meter square on the roof surface. Followed by this, a coarse sand is immediately spread over the hot layer of bitumen at the rate of 0.6 meter cube of sand per 100 meter square of roof surface. Then a 10 centimeter layer thick of lime concrete is laid in proper slope. The entire slope which is given in the lime concrete itself. This lime concrete may consist of 2 parts of lime, 2 parts of surki and 7 parts of brick ballast, which is very similar to what we were seeing in the Jodhpur example. The concrete is well beaten. 2 courses of flat brick tiles are laid on top of this in 1:3 cement mortar. The joints of the top course are pointed with 1:3 cement mortar, and the vertical joints of the 2 successive layers are broken to ensure there is no continuous joint, because water can actually enter through the continuous joints. So, that was if we do lime concrete terracing with the help of tiles. Now, let us move to the next type of terracing, which is called the Bengal terrace roofing. This is used for covering veranda portions mostly. It is slightly sloping, kind of like a example of lean-to roof. So, this we can apply if we have a veranda which needs to be covered with a slightly sloping roof structure. This construction is done by following the following steps. The wooden rafters are placed at 30 to 50 centimeters center to center on a particular slope. The wooden battens are then placed across the rafters. They are placed at a lesser spacing of 15 centimeters center to center. A course of flat tiles, which are usually 15 centimeter cross 8 centimeter cross 2 centimeter, which are well soaked in whitewash, is laid in lime or cement mortar over these battens. So, we have a layer of rafters followed by a layer of battens which are placed across. On top of that, we have a layer of flat tiles. On top of this flat tile, we have to provide some amount of finish. Now, this finishing can be done in 2 ways. Method A is 2 or more courses of flat tiles are laid in mortar. This is topped up with 2 to 3 coats of lime plaster, and the final course of lime plaster is rubbed smooth and polished. So, that is one method in which we can use multiple layers of flat tiles on top of the battens, have 2 to 3 coats of lime plaster, finishing it off with another layer of lime plaster which is polished. Method B is we have a 4 to 5 centimeter thick layer of fine jelly cement concrete which is laid over the tiles. Over this concrete, a course of flat tile is laid. The surface is then fully finished with 2 to 3 coats of lime plaster, the fine coat being rubbed, smooth and finished. So we can either have multiple layers of brick tiles or we can flat tiles, or we can go for a layer of jelly concrete on top of these tiles and finally finish it off with lime plaster in the top after laying a course of another flat tile. The last type of terracing that we can go for is the lightweight flat roof. This consists of aluminium alloy and steel decking. The decking has an additional soffit sheet which is suitably supported on steel beams. So how do we do this type of terracing? We start on top of the decking. A felt vapor barrier is bonded with bitumen. Fiber board or expanded polystyrene is bonded for insulation. This is then covered with 2 to 3 layers of felt roofing material, and the top surface is finished with a layer of white stone chipping which is spread on bitumen to provide for solar reflectability and reduce the heat absorption of this layer. So we are starting with fiber board on hot bitumen, followed by felt on hot bitumen and fine grit finish with cold bitumen adhesive. So these were the various types of flat roofing that we have studied today. Just to recap, the first method we studied was called mud terrace roofing. Second was brick jelly or madras terrace roofing, followed by mud fushka terracing with tile paving. Lime concrete terracing, we can also have lime concrete terracing with tile paving. We have Bengal terrace roofing, and finally the lightweight flat roofing. Now, in addition to the other methods of damp proofing that we had learnt in the previous lecture, where we started with the different methods of damp proofing, followed by what are the materials we can use for damp proofing and how we can do damp proofing at the basement level, foundation level, wall level and intermediate floor level, and finally the roof level, where we have seen how in a flat roofed situation we can use different types of terracing material to ensure waterproofing. These are some of the references for further studying. Thank you so much for tuning in. With this, we end the module on damp proofing. Hope to see you soon.